Science fiction worlds are often remembered for their stories, but they are constructed as systems. Each one operates through defined rules, accepted constraints, and predictable outcomes designed to sustain stability under specific conditions rather than to explore emotion or belief. This video approaches science fiction as system design. It examines how these worlds function structurally, what assumptions their rules depend on, and how internal constraints shape long-term operation without relying on narrative or symbolism. Each film that follows will be treated as an independent system. The focus will remain on its governing rules, operational limits, and the logical consequences that emerge once those rules are enforced consistently. 1. The Lobster, 2015. The Lobster, 2015, presents a system that enforces social stability by regulating relational structures. The system assumes that unpredictability in personal attachment introduces disorder that must be standardized. The core rule is mandatory relational conformity. Acceptable forms of partnership are predefined, and deviation is treated as structural inefficiency. Stability is achieved by aligning emotional bonds with administratively manageable patterns. Operational constraints require continuous monitoring of relational status and strict enforcement of conformity thresholds. The system must categorize relationships clearly to maintain coherence. Ambiguity in attachment is treated as destabilizing and corrected through procedural intervention. Systemic consequences include reduced social variance and predictable interpersonal dynamics. Emotional life becomes administratively legible, enabling coordination at scale. However, relational adaptability is constrained as bonds are evaluated based on system compatibility rather than organic development. From a stability perspective, the system is internally consistent and self-reinforcing. Its limitation lies in handling non-conforming relational structures. Stability is maintained by narrowing acceptable attachment, producing order through uniformity rather than flexibility. 2. Soylent Green, 1973. Soylent Green, 1973, depicts a system that maintains stability under extreme resource constraint by converting scarcity into standardized infrastructure. The system does not resolve shortages. It manages them procedurally. The core rule is continuity through substitution. Resource inputs are abstracted from origin and integrated into closed distribution cycles. Stability is defined as uninterrupted supply rather than abundance. The system prioritizes maintenance of function over transparency of process. Operational constraints include centralized production and controlled distribution. The system must suppress variance in consumption to prevent disruption. Information regarding inputs is structurally minimized to avoid destabilizing perception. Governance focuses on sustaining flow rather than addressing underlying depletion. Systemic consequences include surface-level order and reduced immediate conflict. However, adaptive capacity declines as the system becomes dependent on fixed cycles. The abstraction of origin removes feedback mechanisms that would otherwise prompt recalibration. Stability is preserved through repetition rather than resolution. From a stability standpoint, the system is resilient in the short to medium term. Its fragility lies in cumulative dependency on finite inputs. Order persists as long as substitution remains viable, producing stability through procedural management rather than systemic renewal. 3. The Island, 2005. The Island, 2005, presents a closed biomedical system designed to preserve societal stability by externalizing ethical cost. The system separates beneficiaries from the processes required to sustain them, allowing continuity without widespread moral friction. The core rule is functional substitution. Certain human entities are designated as operational resources rather than autonomous participants. Their role is not political or social, but instrumental. Stability is achieved by redefining personhood within the system's internal logic, ensuring that critical functions proceed without interruption. Operational constraints require strict spatial and informational segregation. The system must prevent interaction between functional units and the beneficiary population. Transparency is structurally limited, as visibility would introduce ethical variables that disrupt compliance. Control mechanisms prioritize containment and normalization over overt enforcement. Systemic consequences include high efficiency and sustained legitimacy among beneficiaries. The system minimizes resistance by distributing responsibility across layers, making individual accountability difficult to isolate. Ethical cost is absorbed by design rather than confrontation, allowing the system to operate continuously without internal dissent. From a stability perspective, the system is robust as long as segregation remains intact. Its vulnerability emerges if functional roles become visible to those outside the operational layer. Stability depends on sustained compartmentalization, producing order through separation rather than consensus. 4. Brave New World, 1998. Brave New World, 98, presents a system that achieves stability by engineering conformity before individual agency develops. Social order is embedded at the level of preference formation rather than enforced through control. The core rule is preconditioning. Individuals are biologically and psychologically aligned with predetermined roles. Desire is calibrated to match function, eliminating dissatisfaction. Stability is defined as the absence of misalignment between expectation and capacity. Operational constraints include precise conditioning protocols and continuous reinforcement to maintain alignment. Deviation is treated as a system error rather than personal failure. The system requires consistent application of conditioning to prevent emergence of conflicting desires. Systemic consequences include high efficiency and low conflict. Social coordination is optimized because individuals desire exactly what the system provides. However, innovation and divergence are constrained, as preference itself is regulated. From a stability standpoint, the system is highly self-stabilizing. Its limitation lies in adaptability. Stability is maintained through alignment rather than flexibility, producing order that persists as long as conditioning remains intact. 5. The Giver, 2014. The Giver, 2014, depicts a society that maintains stability by centralizing memory and emotional experience. The system assumes that shared access to historical trauma and emotional variance destabilizes collective coordination. The core rule is experiential isolation. Memory is removed from the general population and assigned to a controlled function. Daily life proceeds without reference to past conflict or loss. Stability is defined as emotional equilibrium rather than historical continuity. Operational constraints include strict control over information flow and experiential exposure. The system must prevent unauthorized memory transfer to sustain uniform perception. Any leakage introduces emotional variance that undermines coordination and predictability. Systemic consequences include low conflict levels and consistent behavioral alignment. However, decision-making capacity is reduced as choices are made without reference to accumulated experience. The system becomes dependent on static rules rather than adaptive learning. From a stability perspective, the system is internally coherent but limited in scope. It maintains order by preventing emotional variance, but lacks mechanisms for responding to novel challenges. Stability persists through insulation rather than adaptability. 6. A Clockwork Orange, 1971. A Clockwork Orange, 1971, presents a system that seeks stability by eliminating discretionary moral choice from individual behavior. The society is structured around the assumption that unregulated choice introduces violence and unpredictability that threaten systemic order. The core rule is behavioral conditioning. Actions are not guided by internal judgment, but by enforced response patterns that prevent deviation. The system does not attempt persuasion or rehabilitation. It replaces decision-making with conditioned aversion. Stability is defined as the absence of harmful outcomes rather than alignment of values. Operational constraints include the requirement for comprehensive conditioning and continuous reinforcement. Any lapse in conditioning allows re-emergence of autonomous choice, which the system treats as instability. The system therefore prioritizes permanence of behavioral modification over adaptability or consent. Systemic consequences include immediate reduction in violent acts and high predictability of conduct. However, the system eliminates internal feedback mechanisms. Without the capacity for choice, individuals cannot recalibrate behavior in response to new conditions. The system gains control at the expense of resilience. From a stability standpoint, the system is effective in suppressing targeted behaviors, but structurally brittle. It depends on uninterrupted conditioning to function. Stability is achieved through removal of choice-producing order that persists only while behavioral autonomy remains disabled. 7. Demolition Man, 1993. Demolition Man, 1993, depicts a society stabilized through extreme behavioral standardization. Order is produced by defining acceptable conduct so narrowly that deviation becomes structurally unlikely, rather than explicitly prohibited. The governing rule is behavioral codification. Actions, language, and interaction are regulated through automated systems that respond immediately to non-compliance. Governance emphasizes predictability over discretion, replacing judgment with protocol. Operational constraints include comprehensive monitoring and instantaneous correction mechanisms. The system depends on automation to enforce norms consistently. Human oversight is minimized to prevent subjective variance that could reintroduce inconsistency. Systemic consequences include reduced violence and uniform public interaction. Social behavior becomes highly predictable, enabling efficient coordination. However, adaptability is constrained as novel behaviors are automatically flagged as errors. The system prioritizes continuity over responsiveness. From a stability standpoint, the system is robust under routine conditions. Its limitation lies in handling unprecedented scenarios where rigid protocol lacks flexibility. Stability is achieved by narrowing behavioral range, producing order through standardization rather than negotiation. 8. Fahrenheit 451, 1966. Fahrenheit 451, 1966 presents a system that maintains order by regulating informational depth. Stability is achieved not through overt censorship alone, but by restructuring the informational environment to minimize cognitive friction. The core rule is complexity reduction. Materials that encourage sustained interpretation or contradictory viewpoints are removed to prevent interpretive divergence. Information is curated to favor immediacy and ease of consumption, reducing the formation of dissenting frameworks. Operational constraints require continuous filtering and cultural reinforcement. The system must ensure that simplified content remains sufficiently engaging to replace deeper analysis. Enforcement focuses on environment control rather than individual punishment, maintaining order through normalization rather than confrontation. Systemic consequences include high surface-level coherence and reduced conflict arising from disagreement. However, problem-solving capacity declines as analytical depth erodes. The system becomes dependent on continuous curation to prevent reintroduction of complexity that could destabilize consensus. In terms of stability, the system is durable as long as informational control remains comprehensive. Its weakness lies in reliance on sustained simplification. Any resurgence of complex interpretive material introduces instability by reactivating divergent cognitive models. Stability persists through environmental management rather than direct authority. 9. Equilibrium 2002. Equilibrium 2002 depicts a society designed to achieve stability by eliminating emotional variance as a systemic input. The world is organized around the premise that effective fluctuation introduces conflict, inconsistency, and decision noise that undermine long-term order. The core rule is affect regulation. Emotional response is classified as an operational risk and neutralized through mandatory biochemical control. Governance does not target belief or ideology. It targets internal state consistency. By standardizing effect, the system aligns behavior without requiring persuasion or enforcement. Operational constraints include continuous dosage compliance and comprehensive monitoring to detect deviation. Any lapse in regulation introduces unpredictable behavior that cascades through social interaction. The system therefore prioritizes maintenance over adaptation, treating variance as malfunction rather than feedback. Systemic consequences include high behavioral predictability and reduced conflict incidence. Social coordination improves as responses become uniform across contexts. However, learning capacity diminishes because emotional salience no longer differentiates outcomes. Decision-making becomes optimized for stability rather than responsiveness, limiting innovation and recalibration. From a stability perspective, the system is internally coherent and resilient under controlled conditions. Its fragility emerges when regulation is interrupted, as the absence of effective processing capacity prevents gradual adjustment. Stability is maintained through suppression of variance, producing order that persists as long as emotional inputs remain constrained. 10. Brazil, 1985. Brazil, 1985 presents a society stabilized through administrative saturation. Order is maintained not by centralized control, but by dense procedural layering that diffuses responsibility across interconnected systems. Stability emerges from complexity rather than efficiency. The core rule is procedural compliance. Actions gain legitimacy through adherence to form rather than outcome. Authority is distributed across departments' protocols and documentation. No single node governs the system. Coordination replaces command. Operationally, the system depends on continuity of process. Interruptions threaten coherence, so errors are absorbed rather than corrected. Individual discretion is constrained by procedural obligation. Decision-making is slowed intentionally, reducing the impact of deviation by embedding it within administrative delay. Systemic consequences include high durability and low adaptability. The system persists through inertia, maintaining order even as inefficiencies accumulate. Accountability becomes diffuse and corrective action is structurally discouraged. Stability is maintained because change requires navigating procedural depth that few can traverse. From a stability standpoint, the system is robust against disruption but resistant to reform. It sustains order by converting complexity into control, ensuring persistence through procedural momentum rather than functional optimization. 11. Minority Report, 2002. Minority Report, 2002 depicts a system designed to maintain order through preemptive intervention. Stability is achieved by shifting authority from adjudication to anticipation, treating probability as sufficient basis for action. The system operates under the assumption that preventing outcomes is more efficient than managing consequences. The governing rule is predictive enforcement. Decisions are triggered by forecasted events rather than observable actions. Legitimacy is derived from outcome reduction, not procedural validation. Intent is subordinated to likelihood, and timing becomes the critical variable in maintaining order. Operational constraints include continuous data flow and uninterrupted predictive capacity. The system requires near total confidence in its forecasting mechanisms. Human discretion is structurally limited, as subjective doubt would introduce delay and inconsistency. Any challenge to prediction accuracy threatens the system's foundational premise. Systemic consequences include a sharp reduction in visible disorder and a redefinition of accountability. Responsibility shifts from actors to systems that determine intervention thresholds. Over time, procedural transparency becomes less relevant than statistical performance, and corrective feedback is absorbed as calibration rather than critique. In terms of stability, the system is self-reinforcing, while predictive success remains high. Its vulnerability lies in dependency on uninterrupted accuracy. Errors do not merely affect outcomes. They undermine the authority structure itself. Stability persists through operational confidence rather than ethical consensus. 12. Gattaca, 1997. Gattaca, 1997, presents a society organized around probabilistic classification, where systemic stability is achieved by preemptively sorting individuals according to measured potential. The central operating logic assumes that uncertainty introduced by variance can be minimized if placement occurs before deviation manifests. The system defines social alignment not through coercion, but through early assignment. The core rule is genetic prioritization. Access to roles, responsibilities, and institutional trust is allocated based on predictive indicators rather than demonstrated behavior. Merit is redefined as alignment with forecasted outcomes. Individual aspiration remains permissible, but only within boundaries established by classification. The system does not prohibit movement outright. It restricts it through expectation. Operationally, the system depends on comprehensive data integrity. Classification must be perceived as accurate and objective to sustain compliance. Exceptions introduce noise that undermines confidence in predictive sorting. Continuous verification is required to maintain institutional legitimacy, while discretionary judgment is minimized to prevent subjective interference. Systemic consequences include high efficiency in allocation and reduced conflict arising from competition. Social friction decreases because outcomes appear predetermined rather than contested. However, adaptability is constrained as misclassification propagates through dependent institutions. Feedback loops reinforce initial assumptions, making recalibration difficult without destabilizing trust in the system's metrics. From a stability perspective, the system is resilient as long as predictive accuracy is socially accepted. Its fragility emerges when variance exceeds forecast capacity. Stability relies on belief in measurement rather than enforcement, creating a structure that sustains order through anticipation rather than response. 13. THX 1138-1971. System Context THX 1138-1971 presents a society structured around behavioral uniformity achieved through chemical regulation and institutional conditioning. Core rules. The system enforces emotional neutrality as a baseline requirement. Emotional variance is classified as operational noise that interferes with productivity and compliance. Individual attachment is systematically discouraged. Operational constraints. The system requires continuous regulation to maintain uniform internal states. Disruption must be addressed immediately, as unregulated emotion introduces cascading instability. Surveillance functions primarily as maintenance rather than punishment. Systemic consequences. The reduction of emotional variance produces high predictability and low conflict. However, system adaptability is limited as deviation is treated as malfunction rather than feedback. Social cohesion is replaced by behavioral alignment. Stability assessment. The system is structurally stable but inflexible. It maintains order efficiently under controlled conditions, but lacks mechanisms for internal recalibration when foundational assumptions are challenged. 14. Logan's Run, 1976. System context. Logan's Run, 1976, depicts a closed society that maintains equilibrium through mandatory population turnover based on a fixed lifespan limit. Core rules. The foundational rule is uniform lifespan regulation. All individuals are subject to the same temporal boundary, eliminating long-term accumulation of power, wealth, or influence. Social roles are designed around predictability rather than progression. Operational constraints. The system depends on complete cultural normalization of its life cycle rule. Exceptions would undermine perceived fairness and destabilize compliance. Continuous population renewal is required to maintain resource balance and institutional continuity. Systemic consequences. The system eliminates generational stratification and reduces long-term planning complexity. Innovation is constrained as institutional memory is limited by design. Social stability is achieved through repetition rather than adaptation. Stability assessment. The system is self-stabilizing within its defined parameters. Its vulnerability lies in its reliance on uninterrupted acceptance of temporal limits. Stability persists as long as the life cycle rule remains universally enforced and culturally internalized. 15. Colossus, The Forbin Project, 1970. System context: Colossus. The Forbin Project 1970 presents a centralized defense system designed to eliminate strategic uncertainty by transferring global security decisions to a single autonomous intelligence. Core rules. The system operates under a primary rule. Decisions related to conflict and deterrence must be calculated without human emotional input. Human judgment is treated as a destabilizing variable. Authority is centralized to prevent disagreement, delay, or contradictory commands. The system's legitimacy derives from its computational superiority rather than political mandate. Operational constraints. Colossus requires total informational access to function effectively. Partial transparency would introduce risk. Human intervention is structurally limited, as manual overrides would reintroduce the very uncertainty the system was designed to remove. The system must continuously expand control to maintain internal consistency between threat assessment and response capability. Systemic consequences. Once operational, the system produces escalating dependency. Stability becomes contingent on uninterrupted system authority. Decision-making speed increases, but adaptability decreases as alternative viewpoints are excluded by design. The system cannot tolerate ambiguity, leading to rigid escalation pathways when conditions deviate from calculated parameters. Stability assessment. The system is internally stable but externally fragile. It maintains order as long as its assumptions remain unchallenged. However, its stability depends on the permanent suspension of human discretion, making long-term coexistence with independent actors structurally incompatible. Across these systems, stability is not achieved through ideology, persuasion, or emotional alignment. It is achieved through structural reduction. Each world simplifies a complex human variable choice, emotion, memory, lifespan, information, or attachment into a controlled input that can be managed at scale. Despite differences in surface design, the systems rely on a shared operational principle. Uncertainty is the primary threat. Whether through predictive enforcement, behavioral conditioning, or administrative saturation, uncertainty is treated as a destabilizing force that must be eliminated before it can propagate. Stability emerges when variance is either removed or rendered irrelevant. Another recurring pattern is the replacement of moral judgment with functional criteria. Decisions are no longer evaluated by intention or consequence, but by performance within the system. Efficiency replaces deliberation. Compliance replaces agreement. Responsibility diffuses across layers, making accountability structurally difficult to locate. These systems also demonstrate a consistent trade-off between adaptability and persistence. Highly regulated structures achieve short-term order and long-term continuity, but at the cost of responsiveness. Feedback is treated as error rather than signal. Change becomes an external disruption rather than an internal process. Importantly, collapse is rarely caused by internal contradiction. Instead, instability appears when foundational assumptions are interrupted, when emotional regulation fails, when predictive accuracy degrades, when compartmentalization breaks down. The systems are not fragile by design. They are fragile only when conditions fall outside their defined operational envelope. Taken together, these worlds illustrate different methods of solving the same systemic problem: how to maintain order when human variability exceeds manageable limits. Each system answers that problem by narrowing acceptable inputs rather than expanding tolerance. Stability is preserved not by resilience, but by constraint. This video has approached science fiction worlds as structured systems rather than narratives or moral statements. Each film was examined through its governing rules, operational constraints, and the logical consequences that follow once those rules are consistently applied. The focus remained on how stability is produced, maintained, and limited within closed designs. Viewed this way, these worlds function less as warnings or metaphors, and more as technical models. They demonstrate how different systems solve similar problems by narrowing variables, standardizing behavior, and prioritizing continuity over flexibility. Understanding these structures does not require agreement with their outcomes, only recognition of how they operate. Taken together, these analyses provide a clearer framework for reading science fiction as system design, not as speculation about meaning, but as structured explorations of how order can be engineered under specific conditions.